Okay, so once we have the multiplication of fractions down, and that should make our next lesson, adding and subtracting fractions, a lot easier. As long as we know how to add and subtract, then we shouldn't get confused as to what we're supposed to do with our fractions. First thing I have to do is I have to understand that I can indeed add and subtract fractions. However, once I know that I can, I got to look at what I have. What do I have to have in common when it comes to my fractions if I'm going to add them or subtract them? You ought to know by now, and hopefully remember, you have to have a common denominator. Once I have a common denominator, so some of them you will have them, some of them you won't have them. So we'll have to change them, and that's where that multiplication that we did in the last lesson comes into play. Once you've changed them, though, then you keep your denominator, and then you do the math, either adding the numerators or subtracting the numerators. So let's start with just the addition parts of it. Notice I have the created common denominators. Okay, so we had a 3 and a 2, but once we got to 6, then we keep it and we add our numerators together. So I have two practice problems where we have a common denominator, and then we're going to look at not having common denominators. So if I have 2 ninths plus 3 ninths, can I add them? Yes. Do I have the same denominator? Yes. What do I do with it? Well, I'm going to keep it. As long as I know what's there, I'm going to keep it the same. Then I just add my numerators. 2 and 3 is 5. There's nothing I can reduce. It should be an easy problem. Same thing with number 2. Can I add them? Yes. Do I have the same denominator? Yes. What do I do with it? I'm going to keep it. So I know my denominator is going to be 7. Then I just add my numerators. And so I have 2 plus 4, which is 6. 6 sevenths. Pretty easy, pretty straightforward. These are where they get a little bit more complicated because I have to create a common denominator. Can I add fractions? Yes. Do I have the same denominator? No. Well, now I have to do some changing. So what I've always done and showed you to do is if I stack them, I can see things lined up better and what I'm doing. When I put my 6/13 and I stack it to my 14/26, then I look at my denominators. What would the least common multiple be between 13 and 26? Well, multiplying 13 by 2 does give me 26. So that means I can keep this one. So 26 is going to be my denominator. So if that's the case, I got to ask, well, what am I doing to 13 to get a denominator of 26? Well, I'm multiplying by 2. So if I multiply the denominator by 2, I have to multiply the numerator by 2. 6 times 2 then is just 12. So now I have 12 over 26. What do I do with my denominator? Well, I'm going to keep it, and I'm going to add my numerators. Well, 14 and 12 gives me 20. I have 26 over 26. What do we know is true about any number over itself in fraction form? It's always equal to 1. So my answer to number 3 should just be 1 by itself. Now that won't be the case with the next two. I don't have a common denominator, so I'm going to stack them. And I'm going to look and see if my smallest denominator will go into my largest one evenly. 7 is indeed a factor of 21, so I know that works. So I'm going to keep my 21 as my denominator, and I'm not going to change my numerator. That means I have to change my 7, though, into a 21, so I have to know what I'm doing to 7 to get 21. My basic multiplication facts tell me that 7 times 3 is going to give me the 21 that I need. And if I multiply my denominator by 3, I have to multiply my numerator by 3. So 6 times 3 is 18. So I have 18 over 21. So I'm going to keep my denominator because it is now the same. And then I'm going to add my numerators. So when I do that, I end up with 31 over 21, which is an improper fraction. And I can't keep that as my final answer. So I know that my numerator goes inside my division box. I'm going to divide by my bottom number. It is my divisor. And then I see that, well, 21 goes into 31 one time evenly. But I have 10 left over. Once again, my numerator or my remainder is my numerator. My divisor is my denominator. So I end up with 1 and 10 21sts. The only factors I have for 10 are 1 and 10, which only 1 would work for that, and that wouldn't reduce, or 2 and 5. So I know that 10 over 21 is as low as it can go. On number 5, then, I have 6 and 3/6 plus 1/4. still don't have a common denominator. So I stack them and I look, will the 4 go into the 6 evenly? It won't. So just like the last lesson where we multiply by opposite denominators, that's what I'm going to do if I have to. But I could use a smaller number. If I know that 6 and 4 are both factors of 12, I can use 12 instead, and then I might not have to reduce at the end, or at least not have to reduce as much. I like to go sometimes with the smallest one that I can get. If it's a really big number, then I just multiply by opposite denominators. But here, I'm going to multiply by 2 so that I get a denominator of 12. So then I have to know what I'm doing to 4 to get a denominator of 12 as well. When I get my denominator of 12, I have to remember to carry over my whole number. That's where a lot of people forget to do that, and then they just leave it off, and they end up with the wrong answer. But the 6 times 2 is my 12, and my 3 times 2 is indeed 6. So what am I doing to 4 to get 12? Well, I'm multiplying it by 3, which means I have to multiply my numerator by 3. So when I do that, I get 3/12. Now I have a common denominator. Now I can add them, the numerators. So when I do that, I get 6, and 6 plus 3 is 9. 9, keeping my denominator of 12. 6 and 9/12. But I can still reduce that one. So what would we reduce it to? Well, what will go into both of those, 9 and 12? 3, right? So 3 would go into 9 3 times, and 3 would go into 12 4 times. So I know my final answer ends up being 6 and 3/4. Now, some of you might have seen up here, another way you could have started this one out was by reducing this fraction, because 3/6 can be reduced. That's why we end up having to reduce here at the end. And you could have had 1/2 and then found a common denominator of 4. There's multiple ways we can do it. As long as you show me the work, and the work is logical and it makes sense, and I can follow it along and see where you went on your steps, you get the credit. And then you get the credit for having the right answer. Well, what about subtraction? Subtraction works the exact same way. When I look at it, I have to make sure I have a common denominator. And once I have a common denominator, then I can subtract my numerators. It works exactly like the addition does. So when I look at the first two that I've given you, I've made them easy for you, common denominators. So I know I'm going to keep the denominator of 9 and then just subtract my numerators. And 2 minus 1 is 1. So I know that's 1/9. That's easy peasy. That one's pretty easy too. Still a common denominator of 8, so I know I'm going to keep it and subtract my numerator. 7 minus 4 is 3. I get a final answer of 3/8. But what about the ones that don't have common denominators? Well, I do those exactly like I did the addition. I'm going to stack them and look at my denominators then. Will the smallest one go into the largest one evenly? Well, 15 times 3 is indeed 45, so I know 15 is a factor of 45. So I want to keep this one and use 45 as my common denominator. It means I got to change that one to a 45. Well, how do I do that? 15 times what is 45? Well, it's 3. So then I have to multiply my numerator by 3 as well. And 14 times 3, if I can't do it up here, handy dandy calculator, 14 times 3 tells me it's 42. Now I have a common denominator. So now when I have the common denominator, I know I keep it, subtract my numerators, and then check to see if I can reduce. So I have 28 when I take 42 minus 14, handy dandy calculator, 42 minus 14, I get 28, and 45. Well, my factors of 28 are, let's see, 1 and 28, 2 and 14, 4 and 7. None of those go into 45. So that's as low as I can go on that answer. Well, when I have these, I have 26 and 46, or 23 and 46, still not a common denominator. All right, so does my smallest one go into my largest one evenly? Yeah, it does. So I'm going to keep this one, and that 46 is going to be my common denominator. So what do I do to 23 to get 46? I multiply it by 2. And if I multiply it by 2, then I have to multiply the top by 2. That gives me 5 times 2, which is 10. So now I have 10 over 46. All right. I have the same denominator, so I'm going to keep it. And 10 minus 4, well, it just has me a numerator of 6. However, they're both even. So I know I have to be able to reduce. But will 6 go into 46 evenly? It won't, so I can't reduce by 6. So it's just going to reduce by 2. and 2 goes into 6 3 times, and 2 goes into 46 23 times. All right. Now when I look at this one, now I have whole numbers. Well, how does the whole number change the math that I do? Well, I just remember to subtract the whole numbers. So I keep this listed, and then I list that one, keep everything lined up, just like I did before. I look at my smallest denominator. Does it go into the largest denominator evenly? It does. So I know I'm going to keep this one the same. It's just going to be 4 and 16/20. I'm going to be subtracting from that once I get this answer. Well, what am I doing to 5 to get 20? Well, if I multiply by 4 and I multiply the numerator by 4, that would give me a denominator of 20, and my numerator of 2 times 4 is 8. Remembering to carry over my 1 so I don't accidentally leave it off in my final step and end up with the wrong number. All right, so when I subtract, I have to subtract numerators, keep my denominator, but I also have to subtract my whole numbers. So 16 minus 8 is 8, keeping my 20, and 4 minus 1 is 3. But those are even numbers. So what am I going to reduce by? Well, if I reduce by 2, then I would get 4/10. But those are both even also, so I'd reduce by 2 again. If I want to just do it in one step, then I'm going to reduce by 4, because then I only have to reduce one time. So 4 goes into 8 2 times, and 4 goes into 20 5 times. So I know my final answer then is just 3 2/5. So this is not a difficult lesson. Just a warning, when you're doing your homework assignment, there are 3 of them, I believe I put on there, that you have to remember the order of operations. You have to remember what comes first, and you have to do them in the correct order in order to get the right answer. Other than that, it's just straightforward. Can I add and subtract? Yes. I have to have a common denominator. If I don't, I've got to change it to a common denominator. Once I've done that, then I'm going to keep the denominators and either add the numerators or subtract the numerators. Finally, when I get this mixed number or this fraction, if it's an improper fraction, I'm going to convert it. But every fraction I end up with, I'm going to see if I can reduce. If you have any questions as you're working through it, then please come and ask. If not, everyone should be able to get an A on this. Just show me your work and have the right answers, and you're good to go.